Good morning to all. Today we are going to see about zeolite process. It is used to remove the hardness of water. It is also called as one of the external conditioning method. So, in the zeolite process is otherwise called as the permuted process. First we see about what is zeolite. A zeolite is a hydrated sodium aluminosilicate. It is also known as a permutates. So the zeolite is capable of exchanging reversibility its sodium ions of hardness producing ions in water. The chemical structure of zeolite is Na2O, Al2O3, X silicon dioxide, Y water. So X and Y is denoted as number of silicon dioxide and number of water, where X is equal to maximum 2 to 10 and Y is 2 to 6. So types of zeolite. There are two types of zeolites. First one is a natural zeolite, second one is a synthetic zeolite. Natural zeolites are a green color. It contains a non-porous, or it has no porous. For example, natrolite. The chemical formula of natrolite is sodium disodium oxide, aluminium trioxide, and X number of silicon dioxide, number of water molecules. This is a natural zeolite. Second one is a synthetic zeolite. In the synthetic zeolite is also known as a permutates. It has a porous. Porous means holes. The synthetic zeolites containing a pores, and it possesses structures. Structures means gel-like a structure. It is generally used for water softening. They are prepared by heating together china clay, feldspar, and soda ash. Such zeolite possess higher exchange capacity per unit weight than the natural zeolite. So natural zeolite, so the synthetic zeolite is represented as Na2Ze. The sodium ions which are loosely held in sodium zeolite are replaced by calcium and magnesium ions present in the water. So next one is a process. How to work the zeolite process. For softening of water by zeolite process, hot water is percolated at the specified rate through a bed of zeolite kept in a cylinder. When the hot water is passed through the bed of sodium zeolite, then the exchanges its sodium ions with the calcium and magnesium ions present in the hot water to form calcium and magnesium zeolite. The various reaction taking place during softening process. So the reaction now zeolite process is calcium bicarbonates react with the sodium zeolite to form calcium zeolite, then the removal of sodium bicarbonate. Like that, magnesium bicarbonate reacts with the sodium zeolite to form magnesium zeolites, and the byproduct of sodium bicarbonate. So same calcium sulfate and magnesium sulfates reacts with the sodium zeolite to form calcium zeolite and magnesium zeolite in the removal of sodium sulfate. So next one is the calcium chloride and magnesium chloride reacts with the sodium zeolite to form sodium zeolites and magnesium zeolite, the removal of sodium chloride. The softened water is enriched with large amount of sodium salts which do not cause any hardness but cannot be used in the boiler. Next one, regeneration. How to regenerate the resin. After some time, the zeolite is completely converted into calcium and magnesium zeolite, and it ceases to soften water. That means it gets exhausted. The exhausted zeolite is again regenerated by treating with the 10% of sodium chloride. So the calcium zeolite reacts with the sodium chloride to form sodium zeolite and calcium chlorides. Like that, magnesium zeolite reacts with the sodium chlorides, reacts with the to form sodium zeolites and magnesium chloride. So the exhausted zeolite is calcium zeolites and magnesium zeolite. The washing is calcium, washing out materials, calcium chlorides and magnesium chloride. So the limitation of the zeolite process. First one, if the supply of water is turbid, the suspended matter must be removed by using coagulation or filtration process before the water is admitted to the zeolite bed. Otherwise, the turbidity will clog the pores of zeolite bed, thereby making it inactive. Second limitation is, if water containing large quantities of colored ions such as manganese and iron, they must be removed first, because these ions produces manganese and iron zeolite, which cannot be easily regenerated. Mineral acids, if present in water, destroy the zeolite bed, and therefore they must be neutralized with the soda before admitting the water to the zeolite softening plants. So advantages. First one, it removes the hardness almost completely, and water of about 10 ppm hardness is produced. ppm means parts per million. So second one is the equipment used is compact, occupying a small space. Third one is no impurities are precipitated, so there is no danger of sludge formation in the treated water at the later stage. Fourth one is the process automatically adjusts itself for vibration in hardness of incoming water. It is quite clean, it requires less time for softening, it requires less skill for maintenance as well as operation. So the operation is also easy for the zeolite process. It can't form any sludges in this process. This method is one of the cheapest method, because the regenerated zeolite can be used again. We can use the regenerated zeolite. This equipment is compact and occupies small spaces. Next one is the disadvantages. Disadvantages of zeolite process. The turbid water cannot be treated because it blocks the pores of the zeolite bed. Second one, acidic water cannot be treated because it decomposes the structure of zeolite. So third one is the softened water containing more dissolved sodium salt like sodium bicarbonate and sodium carbonate. When such water is boiled in boiler, calcium carbon dioxide and sodium hydroxide is produced, resulting in boiler corrosions and causing embrittlement. When the water containing fluorine and manganese cannot be treated because regeneration is very difficult. This process cannot be used for softening brackish water because brackish water contains sodium ions, so the ion exchange reaction will not occur. There are some differences between zeolite process and demineralized process, that means ion exchange process. Zeolite process exchanges ions cations only, but the demineralization process or ion exchange process exchanges cations as well as anions. In zeolite process, acidic water cannot be treated because acid decomposes the zeolite. In the demineralization process, acidic water cannot be treated. Third point, the treated water containing relatively large amount of dissolved salt, which leads to priming, foaming, and caustic embrittlement in boilers. The treated water does not contain any dissolved salt, hence there is no priming and foaming. Last one is water containing turbidity, iron, manganese cannot be treated. In the demineralization process, here also water demineralization process, the water containing turbidity, iron and manganese cannot be treated. So these are the points to zeolite process, that means external condition. Thank you.